Good day, everyone. Welcome to my YouTube channel. This is Teacher Ryan, and this is my third video on mental math for all. On this video, I will continue my series on mental math and particularly in mental multiplication. And I'm going to feature a unique math or mathematics system, the Vedic math, and some of its sutras or techniques. So without further ado, let's get started. You may be asking, what is this Vedic math all about? Vedic math is a unique system that offers non-conventional methods or ways in doing calculations. The word Vedic comes from the word Vedas, which means knowledge. And this Vedic math was part of the Vedas. And obviously it originated from India. However, some mathematicians in Europe, particularly in England, developed it further and propagated it in UK and in some parts of Europe. And eventually they also brought it back to India and the other parts of the world. Now for this video, I'm going to make use of some of the notable word formulas or sutras of Vedic math, for mainly in doing mental multiplication. So in Vedic multiplication, there are three procedures or three ways that are used to perform Vedic multiplication. These are the vertical multiplication, crosswise, and the left to right. So to show that, to illustrate that, I have here an example, 23 times 45. The first step is to do the vertical multiplication, which also means to multiply the first digits of our factors. So for 23, the first digit is 2, and in 45, it's 4. Multiplying 2 and 4 gives us 8, or in this case, it should be translated to 800. But we can also take that as 8 for easy mental computation. Next is we will do the crosswise multiplication, meaning we will multiply the first digit of the first factor by the second digit of the second factor, and conversely the first digit of the second factor times the second digit of the first factor. So here in 23, 2 is to be multiplied by the 5 of 45. So that's 2 times 5 plus 4 times 3. So 2 times 5 is 10 plus 4 times 3, 12. The answer is 22. Now, here we will only need the last digit of 22. So what we will do with the first digit is to carry that over, or to add it to our first partial product, which is 8. So 8 plus 2 is 10. And then we will attach the 2, and it becomes 102 or 102. The third step is to do again the vertical multiplication, which is to multiply the last digits. The last digits of our factors are 3 and 5. 3 times 5 is 15. Again, we only need the last digit, which is 5. So what we will do is to add the first digit of 15, which is 1, to 102 or 102 to get 103. And then we will attach the 5 to get the final answer of 1035. Now in doing this general method, which is to do the vertical crosswise and then the vertical again. We can also associate um, the correct values. I'll be showing that in the next example. For our next example, we have 63 times 42. First is to do the vertical multiplication, which is to multiply the first digits, 6 of 63 and 4 of 42. 6 times 4 is 24. That should be translated as 2,400, adding two zeros, since we are multiplying 2 by 2 numbers. Next is to do the crosswise, which is to multiply first digit of the first factor by the second digit of the second factor, and the first digit of the second by the second digit of the first factor. So we have 6 times 2, that's 12, plus 4 times 3, that's also 12. So 12 plus 12 is 24. Since this is our second partial product, we will attach the 0 to 24 to have 20 or 240. Now we will add this to our first partial product of 2,400. 2,400 plus 240 is 2,640. So at this point we have 2,640, and now we will go to the last step, which is to do the vertical again, but this time multiplying the last digits. So we have 3 times 2, that gives us 6. And this 6 will be attached, since we only have one digit here, we will attach it to 2,640. No, not attach, but add it to 2,640 to give us 2,646. Now in this case, we still perform the general method of Vedic multiplication, vertical, crosswise, vertical. However, we used the translated value or the correct value. At this point, I would like to feature some special multiplication tricks which are also based from Vedic multiplication techniques. The first case is a case wherein our factors are a little over the powers of 10 or base of 10. So what are those powers of 10? We have 10 to the power of 1, which is also 10, 10 to the power of 2, which is 100, and 10 to the power of 3, 1000, and so on. So the powers of 10 are 10, 100, 1000, 10,000, and so on. So here in this case, the condition is that our factors are greater than, a little greater than the powers of 10. So to illustrate that, I have here an example. It's 17 times 14. 17 and 14 are both near or close to 10. Now let us check the distance. 17 is 7 away, that's plus 7 away because it's greater than 10. 14 is 4 away from 10. Our first step is to cross add. Okay, so we will take the first factor, in this case 17. 17 times 14, so 17 is our first factor. And we will add the ones digit of our second factor, which is 4. So 17 plus 4 is 21. Now we can also say we cross add 17 plus 4, the distance of 14 from 10. So 17 plus 4 is 21. But since this is close to 10, and to check there's only one 0 in 10, we will attach a 0 to 200 to 21, and it gives us 210. Second step is to multiply the distances. So 17 is 7 away from 10, 14 is 4 away, So we will multiply 7 and 4. Or we can simply say we multiply the ones digits. 7 times 4 is 28. And we will add this 28 to 210. 210 plus 28 is 238. That's the product. That's quite easy, right? To get a hang of this trick, I have here two additional examples. First, it's 105 times 109. 105 is 5 away from 100 and 109 is 9 away. So here we can cross add. We will take the first factor, that's 105, times 9, which is the distance of 109 from 100. So 105, not times but add. 105 plus 9 is 114. Second step is to multiply the distances. So 105 is 5 away, 109 is 9 away. 5 times 9 is 45. Now, getting these first and second steps, our third step is just to attach these two. So it's 114 and then we attach 45 to get the final answer of 11445 or 11,445. Quite fast, right? Second example, we have here 1012 times 1019. 1012 is 12 away from 1000 and 1019 is 19 away from 1000. So we will take again the first factor, which is 1012 plus the distance of the second factor from 1000. So 1012 plus 19, that's equal to 1031. 1031. Second step is to multiply the distances. That's 12 and 19. 12 times 19 is simply 228. Now, since 228 has 3 digits, we can directly attach it to our first partial product, which is 1031 or 1031. Now, attaching 228, 1031, 228, oh, that's 1,031,228, our final answer. Quite fast, right? So this is the first case of this trick. For our second case, or case 2, the condition is that our factors are close to powers of 10. However, they're a little less or slightly less than those powers of 10. So to illustrate that, I have here an example. It's 96 times 98. 96 is 4 less than 100. 98 is 2 less than 100. Now, since this is less than, I use the negative sign. So 96 is negative 4 away from 100 and 98 is negative 2 away from 100. The negative sign would be useful because in our second step or next step, we will be doing the cross addition with a negative. But we can also do the cross subtraction in this case. So our first factor is 96 and we will subtract 2 because 98 is 2 away from 100. So 96 minus 2 is 94. If we do it on the other pair, on the other end, like 98, we will also get 94. So 98 minus the distance of 96 from 100 is 4. 98 minus 4 will also bring us to 94. So this 94 will be our first part of our product. Next is we multiply the distances. So again, what are the distances? We have 4 for 96 and 2 for 98. 4 times 2 is 8. However, we need to have 2 digits here, so we add a 0 to 8 and then we attach 08 to 96 to 94. 94 and then 08, it gives us 9 9408 or 9408. To fully grasp this trick or technique, I have here two additional examples. First is 97 times 92. First, let us check the distances. 97 is 3 away from 100, our base, or a power of 10, and 92 is 8 away from 100. Then we will cross add, or cross, I mean, we will cross subtract since our factors are below or less than the power of 10. So let's have 97 minus 8, since 8 is a distance of 92 from 100. 97 minus 8 is 89, and then next step is to multiply the distances. So we have 3 for 97 and 8 for 92. 3 times 8 is 24. The final step would be to annex or to attach these two partial products. So we will connect 89 or 89 and 24 or 24. Hence we have 8,924 as our final answer. Second example, we have here 989 times 992. 989 is 11 away from 1000, and 992 is 8 away from 1000. Next, we will cross subtract. Still make use of the first factor. That's 989 minus 8, since the second factor is 8 away from 1000. 989 minus 8 is 981. Next, we will multiply the distances, which are 11 and 8. Okay? And it is quite easy. 11 times 8 is 88. Hence, however, we need 3 digits here. So we add 0 to 88 to make it 088. So remember, we have 981 as our as our partial product in our previous step, and we are now ready to attach 088. So our final answer should be 981,088. Case 3 requires that one of the factors is less than the base or less than the power of 10, and the other factor is greater than the power of 10. To illustrate this, I have an example here. It's 107 times 95. Still, we need to check the distances from the base. So in this case, our base is 100, since both numbers are close to 100. Now 107 is plus 7 away from 100, meaning it's 7 more than 100, and 95 is negative 5 away from 100 because it's 5 less than 100. Next is to cross add. I will use the first factor again, although even if I use the second factor, I will still get the same result. Say 107 plus or minus 5, since the distance of 95 is negative 5, so I will be subtracting. So 107 minus 5 is 102. If I will use the other pair, say I will use 95 and add 7, since 107 is 7 more. 95 plus 7 will still bring me to 102. Okay, so my first partial product here is 102. However, in this step, I will be appending, or I will be annexing 2 zeros. Now, where did I get the 2 zeros? I got it from the two zeros of our base or of our power of 10. Since our base is 100 and there are two zeros in 100, I will be appending or attaching two zeros in 102. And with that, I will have now 10,200. Now I do that because in the next step, I will be subtracting. The next step would be to multiply the distances. 7 or positive 7 times negative 5 is equal to negative 35. And I need to add that to 10,200. Adding a negative number also means subtracting it from the the bigger number. So this is 10,200 minus 35 is equal to 10,165, which is the final answer, by the way. So the difference of this technique or this trick is that you need to append two zeros in this part because in the next step you will be doing subtraction. Subtraction is always part of this because our two factors have opposing distances. I mean, one is positive or one is greater and the other is less than. To understand this trick better, I have here additional examples. It's 89 times 102. 89 is 11 or negative 11 away from 100, and 102 is positive 2 or 2 away from 100. Next, I will do cross addition. That's 89 plus 2 is equal to 91. But that should be translated to 9,100 by adding or attaching two zeros, since our base is 100 and 100 has two zeros. Next step is to multiply the distances. So we have negative 11 times 2, and that is equal to negative 22. Adding negative 22 to 9,100, that's 9,100 minus 22 is equal to 9,078. Next example is 1,005 times 997. 1,005 is plus 5 away from 1,000, and 997 is negative 3 away from 1,000. Doing the cross addition, 1,005 plus negative 3, or that's also equal to 1,005 minus 3 is equal to 1,002. But this case again should be translated as 1,002,000. Why? Because we need to attach three zeros since our base is 1,000 and 1,000 has three zeros. Next is to multiply the differences, which are positive 5 and negative 3, and that gives us negative 15. Subtracting 15 from 1,002,000, that should give us 1,001,985, and that is our final answer. Thank you for watching. Please take time to subscribe and like this video, and also share this with your friends. God bless and see you next time.